Alright, so let's look at question 8. Another system of linear equations. We've got to use row reduction to reduce it to row echelon form. I've already put it in an augmented matrix for us. So I got to get this down to zeros and ones. So 0, 0, 0, looking for here. There's obviously an issue. We're gonna have a k in the middle of it all, and this k minus 6 is also going to cause us some trouble. Let's start by getting these two to 0 in our first step. So first line remains the same. Second line, then I'm going to use row 2, and I'm going to add twice row 1. So I'm going to get 0, 8, minus 1. That's 1 take away, 2. And okay, so this is row 2, which is 3 plus 2. So it's going to be 3 plus 2k. Alright, that's already looking a little bit awkward, but that's okay. We'll deal with it. And getting this one to 0, I'm going to use row 3, take away 5, row 1. No, 5, row 1. Okay, so that's 0 anyway. Row 3, take away 5, row, not row 1, 2, sorry. 5, row 2. No, it is row 1. My bad. Row 1. So that's going to give negative 16. Oh, k minus 6, take away 5 times minus 1, so that'd be taking away minus 5 would be adding 5. Okay, so that's k minus 1. And the last term then, it's going to be a bit tricky again. Minus 3 minus 5 times k, okay, that's not too bad. Minus 3 minus 5k. Alright. Okay, now let's get this 16 to a 0. Just going to do that. I'm not going to bother getting the other ones down to 1. It's the 3 zeros that we care about most. So this line is okay, and I'm going to leave row 2 as is. 3 plus 2k. Row 3, then I'm going to add, I think, if I look at this, if I add twice this, I'm going to get 0. So if I add 2 or 2's, I'll get 0. All right, 0, 0 is what I wanted. Now, row 3, k minus 1 plus twice that, that's going to be k minus 3. And row 3, this, so plus twice this. 3 anyway in the numbers. And minus k, yes, because there's 4 here, and yes, okay. All right, so hopefully you got that. You can always use a bit of rough work. You'll have more, if you want to use more room, that's totally okay. So that's it, done. You could divide this line by 8 if you wanted, but you don't need to. All right, so part B. Show that for one value of k, the system has infinitely many solutions. Find the solutions. All right, so for one value of k, well, that means that we want all the last line, we want all this last line to be zeros. So, and that occurs, well, if k was 3, we get 3 minus 3, which is 0, and 3 minus 3, which is 0. So that's all. So if k is 3, so when k equals 3, that gives me a last line of zeros, which is our infinitely many solutions, which is what we want. In that case, then, we let z equal a new parameter t, and then we move along to get the solutions. So we take the second line, 8y then, minus 1t or t equals, well, this is interesting as well because you've already said k is 3, so you have to keep k as 3, and that's going to equal 3 plus 2 times 3, which is 9. Rearranging this, you get y is equal to t plus 9 all divided by 8 because it's 8y. Now we have y, we have z, now we must find x using row 1. So once again, we've got to use row 1 here, 1x, so x plus 4 times y, x plus 4 times this, minus, well, 1 times t is still just minus t, and we know that equals 3 now. Okay, we can do some rearranging of that, and I'll leave that up to you. I have my answer here as t minus 3 over 2. So hopefully you got that. Okay, so there are my 3 solutions in the case of k being 3. Part C then was show that there's a unique solutions for all the values of k, and write this solution in terms of k. So if k doesn't equal 3, so k won't be 3, let's have a look at that system. So we don't know what k is, but we look at this last line, and we have k minus 3 times z. So remember, k minus 3 is the coefficient of the z term, and that equals 3 minus k. Okay, well, let's see, can we get a value for z out of that? If I divide both sides by k minus 3, I get 3 minus k over k minus 3. Okay, that's not quite going to divide into each other yet, but it will in a second. If I multiply this line, or either line, by minus 1, if I multiply the top line, might be easier, by minus 1, so I get a k minus 3 inside the brackets, because minus k plus 3 multiplied, yeah, okay. And then on the bottom I have k minus 3. Well, z will equal minus 1. So therefore it would have a unique solution for all other values of k, because these k's will always cancel out. So if k was 6, they'd both be 6, and we both get minus 1. So nice. So we do get a unique solution, one solution. And we must find that one solution then. When we know that z is minus 1, we can sub minus 1 in and find all of those answers, the same as we did over here, except for even easier. Oh, well, maybe not even easier. Let's look at just row 2, and then I'll leave you do row 3 on your own. So from row 2, where is it? 8y minus, well, at the moment it's minus z, so z is minus 1, so it's minus minus 1, and that's going to equal, well, 3 plus 2k. Now, we still don't know what k is, so we got to leave k as it is. It's not the same value as over here, definitely not, because that gave an infinite number of solutions. In this, I'm going to have to leave k, because although for z that the k's would well, cancel each other out, I suppose you could say, in this case we still don't know what k is, so we've got to have k in this answer, unless it also cancels each other out, which we've got to work. So that's going to be plus 1, that's adding to both sides, that's going to make that a 4. No, a 2, sorry, that's going to be, so that's plus 1, subtracting 1 from both sides makes that a 2. So it's going to be y is equal to 2 plus 2k, all divided by this 8. And that simplifies down to, well, you could rearrange it, k plus 1 over 4, or 1 plus k over 4. So that's why you can sub that in and z minus 1 into same as we did here. And I'll just give row 1, then x will work out as minus 2. So the k's do cancel if you sub it in. I can go through that in class if you're not entirely sure how to finish that. All right, moving along. Use the principle of mathematical induction. Yes, to prove that this is divisible by all. So let's just go straight into it. Is it true for n equal to 1? Well, let's check it. So we got 8 to the power of 1 plus 2 minus, so I'm perhaps not writing this out as fully as I could do. Is it divisible by 49? Well, let's see. Well, you can put in a variable here if you want. Is it divisible? 8 times 8 to the power of 3. Okay, you're going to need your calculator for this. I know that it's, if you put this all into the calculator, I think you get 490. 490. And is that divisible by well, it's definitely divisible. A would be 10. So left hand side equals right hand side. So it's true. So it holds for when n equals 1 holds. So we can move on with our lives to letting n equal to k, which is a quick step assumption. Okay, we're going to assume that that's true then. I've already used A, so I'll use B. Okay, there's some other. And also B is an element of positive integers. Okay, awesome. All right. Now we got to use our proof. N equal to k plus. Okay, so we've got to replace these k plus 1s on the left hand side. So that's k plus 1 plus 2 minus 7 k plus 1 minus 15. That's 49. Let's use C, another C, and you can excuse me. And C is once again a element of Z plus 2. Okay. All right, we need to make sure that this, well, what I'm looking for at the end of this is, sidebar over here, is 49 times something. Whatever's in here, great. But if it's 49 times something, it's divisible by 49. If I can get that out of this mess, that's what I want. I got to use the inductive step. So if I can get this somewhere out of this, means I can just pop in 49 times b, which is definitely divisible by 49, which would be a big advantage for me. Okay, so let's try and squeeze this out somewhere out of this, for want of a better term. All right, I need a k plus 2. Now I have a k plus 1 plus 2. Well, that's like saying 8 to the 1 times 8 to the k plus 2, because you would add the powers, wouldn't you? Okay. Well, let's multiply this out, and that's 7k minus 7 minus 15. Okay, so I'm just working on the left-hand side here. Just doing the left-hand side of the equals. Okay, let's just make that 8 times 8k plus 2 minus 7k minus 22. Okay, so I have that. Still looking for my this. Maybe if I force it. So, yeah. Okay, so I'm going to kind of force it. Watch what I do. See if this works. So 8 times 1, is this just 8? That's going to be times, and I'm going to say, okay, it's there. 8k plus 2. I'm going to put minus 7k minus, so I'm just putting this in, minus 15. Just putting it in, because I know it's 8 times. I almost have it now, but so this is, let's say I haven't used this. What do we have? Minus 7k minus 22. Okay, let's say I haven't used it. I just have shoved this in, minus 7k minus 15 with this. So I've introduced this to the equation. But as long as I've introduced, like, that's minus 56 really k, because I was multiplied by 8 and multiplied by this multiplied by 15. And I've introduced minus 15 times 8 into the equation. Well, I've subtracted it really from the equation. If I've introduced that, that means I have to do the opposite thing to keep the, so it's like introducing a minus 5 to the equation and then adding a 5 to keep it nice and balanced on that left-hand side, which I'm going to do. So what I've added, or subtracted 56k, so I'm going to add it at the end here. And I've added, well, 8 times Oh, 80, 120. So so I need to add 120. So hopefully you followed that step. I just pop these in, then I'm going to add them on in the end. So they're negative here, and I'm just going to do the positive there. And this may be the key to this. Okay, so from inductive step, I can say that A is now 8 times 49b from induction step. Okay, using n equals k, using 2, using assumption. Alright, that's great. Now hopefully we get 49 or a multiple of 49 of all this. So 56 take away 7, oh look at that, plus 49k. And 120 take away 22 is 98k, or just 98. Well, fancy that. So this is definitely divisible by 49, 8 to the 49b. And this is divisible, you can take 49 out of that, that's k plus 2. They're both divisible. Alright, so that's divisible by 49, that's divisible by 49. You could combine them all together if you want and leave the 8 inside the bracket, but I've run out of room here, so I'm going to say that it's proved by the principle of mathematical induction. Just to say the last line, since n equaled 1 is true, and k is equal to plus n is equal to k plus 1 is true, then it's true for all n positive integers.